Good afternoon, everyone. Would everyone please start taking their seats? We're going to start the talk shortly. I just want to make a couple of announcements. First of all, I want to welcome everybody. But please turn off your cell phones and pagers. And for the photographers, only the first minute of the program is flash allowed. After that, no flash. Thank you very much.
It is good, and they've really done a good job, I think.
They have Xerox stuff down there?
There's an
Yeah, but Xerox...
there's a Star.
Sigma.
Oh, Sigma. There is a Sigma 5 there. Sigma 5 there. Yeah.
So much like cards and
I know, when you think about it. Think about it.
The only reason we know the history of craftsmen very well because of all sorts of patent issues we've run into. We have to go over to Europe and find Worth and say, this thing. AT&T sued us on that crazy movie man. It's even about a name. It's the X Windows system.
Well, this is Rob Pike's patent, probably. Yeah.
It's the Pike patent.
Right.
So it forced us to become like better than any curator ever will have time to be to know the history of Windows systems. Patents are good.
They will. They will. It's the good and bad of our patent system.
Yeah. Well, we're on both sides of that. Okay.
Yeah, I think. People in the patent office have a little more time. It's amazing. These guys basically have no time to search anything other than the patent archive and the references that are in the patent submission. So if there's a reference to a vital piece of work that's not in the patent submission, they can't find it.
And it's outside their expertise. Yeah. To help out with this, which had a modest impact. The key thing is, we want, what industry is saying is, as long as you stop taking patent revenue from the general revenue, just make it self-sustaining and find double patent. But they have reason. But the backlog now, our average issuance is now more than 5 years from filing, which, given the submarining and the opaque,
Yes, exactly.
insane.
It is insane.
Although you could it'll probably work well for him.
And then you live.
Case, which we hoped would
I thought we were going to watch the.
Welcome. Computer History Museum. Why do we have a Computer History Museum? We'll take a scientific approach to this and dissect this problem into 3 parts. 3 words: Computer History Museum. I'm Dave House, Vice Chairman of the board. The first word, computer. For 50,000 years, there were no computers. And then suddenly, in my lifetime, there are computers everywhere. Every piece of equipment with a power cord and a battery today seems to have a microprocessor associated with it. And from this time on, there will be computers everywhere. Computers have done to the brain what the lever and the engine did to the muscle in civilization. They have changed the world forever. It's an important change in civilization. Well, second word, history. Why is history important? We can learn 2 ways: experience or sitting at the feet of the master, learning from people who went before us, the university method. You know what experience is, don't you? It's something you get right after you need it. Over time, civilization developed the university system of learning from past experiences, mistakes often more important than successes. It's important that we capture the history of this important change. Third word, museum. You're in what will become the world's largest museum. We're doing a great job on the history part. The museum part is still in our future. We have the largest collection in the world. We have got a number of programs. What we don't have in place today is the educational content with displays for the public that really communicate this. We're busy capturing the history today. Our next phase will be in producing it. Our vision is to explore the computing revolution and its impact on the human experience. We're not just about hardware and artifacts. We're 25 years old. We started out in a digital equipment museum or building in Massachusetts, quickly moved to Museum Wharf in Boston. In 1996, we moved the history collection to some dilapidated old World War II buildings nearby at Moffett Field. And now, last year, we moved into this facility where we have moved most of our collections, our visible storage, and our administrative offices. And we intend in the future to build displays and exhibits. Today, we're in phase 1. We have visible storage downstairs. If you go through there, you're going to see a lot of hardware, and you might get the wrong impression that we're really just about hardware and old iron. We're about the stories, we're about the software, we're about the technology, we're about the successes, and we're about the failures. Our first exhibit, professional exhibit that we are designing now, features software, and it specifically we're looking at the stories and the history of the development of chess software. An important event that we do every year is recognize our fellows, the great pioneers and contributors. There's still time to buy tickets to the October 19th Fellows Dinner coming up soon. Whoops, if I can move back. Can't move back. Magic.
Bill, maybe he needs some help.
And the next version.
Thank you. So the next phase, phase 2, is about exhibits. And it's about computing's impact on the human experience. It'll include a number of different areas, including software, storage, networking, the internet, human interface, and components and processors, semiconductors, etc., with various focus areas as well as a timeline of all computing history. Now I guess he's advancing the slides. So what do we need next? We need you to get involved. You can get involved lots of ways. Volunteer. We have lots of volunteers. Join a committee. Bring a friend to an event. Attend events yourself. Tell your story through our speaker series, through our video history or audio history series. Donate an artifact. Bring your things into the museum. And finally, get involved through your financial contributions. Downstairs on the wall, you'll see the plaques for our annual campaign and our capital campaign. We've got a capital campaign to raise a total of $100 million. We're at $56 million today and climbing, so please contribute. Now I have the honor to introduce our speakers, who actually need no introduction. I mean, how can you say something new about these guys? John Hennessy, president of Stanford University, became provost in 1999, was chair of the computer science department, director of the computer science lab before that. But John is a man who lived two lives. He's also an entrepreneur. And in 1981, he began a research group on reduced instruction set architecture and computer architecture. And in 1984, he formed MIPS Computer Systems and brought RISC, which since I was at Intel running the sys side at that time, gave me a big headache. Bill Gates, I mean, everybody knows Bill. 75, he started Microsoft and created one of the largest market cap organizations in the world. I don't remember when I first met Bill. It was back, I know, when Apple was the computer of choice, and he and I were trying to convince this large East Coast company to develop a personal computer around our products. It worked out pretty well. And Bill and I, during the 13 years that I ran microprocessors at Intel, had a lot of experiences. Some of them I think he liked, and some of them he didn't like. We have, the two companies certainly do have a great relationship. Bill also lives two lives, and he has really set an example in the industry for philanthropy. The Bill and Melinda Gates Foundation is endowed with $27 billion, that's a billion, billion dollars, and does tremendous amount of things for people in a number of causes around the world. Before we start the discussion, though, I have a piece of history that our curators are really still researching, but we'd like to give you a view of computer history.
From humble beginnings as a series of switches and lights, the personal computer endured triumph and tragedy on its way to becoming a cultural phenomenon. Behind the technology. Tonight, we take a look back on the wild and magical journey of the personal computer. And it all begins with the Altair. To many, the Altair put personal computing on the map. With a powerful array of 15 toggle switches, the Altair lit a young industry on fire.
That was one hell of a computer. I mean, the things we could do with an Altair and the feel of those switches. Most people don't realize all the amazing solutions that utilize the Altair. We had them in.
You know, the thing most people overlook when it comes to the Altair is its state-of-the-art industrial design. Look at it. The beautiful blue color, its fundamental simplicity. Sounds familiar.
Personal computing was brought to the next level with the introduction of DOS, a new operating system that brought more power to the computer. Though difficult and cumbersome, DOS still retains its magic among certain die-hard fans.
I've been a big fan of DOS for a long time. I love DOS. But not as an operating system, though. It's a terrible operating system. And musically, it's very interesting. I used to have this record that I was working on. It went like the C, the prompt, the C, the prompt, the C, the prompt, the C, the prompt, the C, prompt. But that didn't really go over too well.
While Microsoft was working on a DOS-based graphical user interface, a young company in Cupertino, California, released its own GUI operating system.
It's called the Macintosh.
And thus began a rivalry that would become legendary, even the subject of a made-for-TV movie starring Anthony Michael Hall.
You know, I gotta be candid with you. Preparing for this role as Mr. Gates was brutal for me. The caffeinated beverages, the cold pizza, the whole no sleeping thing, the no shower thing. But you know, I had to do what I had to do as an actor. You got to get inside the character, you know. And this character was a serious geek.
That guy's supposed to look like me? Come on, he's a geek.
As DOS continued to evolve, Microsoft developed a new graphical user interface called Windows. The job of promoting Windows fell to Microsoft's high-energy pitchman, Gates' former Harvard classmate, Steve Ballmer. Ballmer took Microsoft's message to the airwaves for the first time with his characteristic subtlety.
That's right, all these features in Reversi, all for just, how much did you guess? 500? 1,000? Even more? No, it's just $99. That's right, it's $99. It's an incredible value, but it's true. It's Windows from Microsoft.
The PC continued to grow rapidly in the ensuing years, adding thousands upon thousands of different applications, some of which were just simply far, far ahead of their time.
Yes, we did a lot of testing with Microsoft, Bob. In trial after trial, it was a smashing success. When Bob failed miserably in the marketplace, we couldn't understand it. I mean, the monkeys had absolutely loved it.
Good job!
This one, even the energetic Ballmer couldn't say.
How cost is this? 5-carat Teflon-coated NT-enabled zirconium moon ring at no extra cost. Buy now, buy!
In the early 90s, a new phenomenon evolved from the formerly obscure military network called ARPANET. The Internet, a vast array of sites all over the world. But there was one problem: how to navigate it all.
We developed the browser so that people could navigate the internet and do things like buy and sell, read the news, learn new things, view art. So yes, I invented the browser. Since then, nothing.
Once the internet became easily accessible to nearly everyone via the browser, the new phenomenon began to grow day by day.
When I became president on January 20th, 1993, there were only 50 sites on the internet. 50. By January 21st, there were 51. January 22nd, 52. January 23rd, 53. January 24th, still 53. That was a Sunday.
There soon began to be something that was called the Internet Bandwagon, and either you were on it or you were off it.
It was very clear to me that the internet was where everybody was going to go. It was especially clear to me after everybody had already gone there.
People seem to think that Microsoft, quote, missed the boat with the internet. Not at all. The whole thing was my idea. I told Bill, this internet phenomenon is bad news. I'm staying out of it, and I think you should too. So then missing the boat was really nothing more than a principled business decision on their part. Or maybe they just missed the boat.
Then, as suddenly as it had risen, the hype of the internet began to crumble, and the economy with it.
Now, many people seem to blame you, for the dot-com crash and all the terrible ensuing economic fallout.
But I'm just a puppet.
Today, the hype is gone, but the PC has continued to grow into many areas that could never have been foreseen in the infancy of the Altair. One shining example, the tablet PC, which recently launched with a totally new handwriting recognition technology called digital ink. Industry experts have been amazed by this innovative breakthrough.
Oh, a totally new handwriting technology. You mean like the Newton had in 1992?
The PC is also finding itself with all new form factors that feature sleek industrial design.
Oh, sleek industrial design.
The PC is even broadening itself with further development of handheld versions, which carry ever richer functionality.
Oh, a handheld computing device with broad functionality.
Join us next time on Behind the Technology, when we examine the wild, dangerous, and exciting world of the database software business. Behind the technology.
Why is it that our curators are shaking their head? I don't understand. Okay, take it away, John and Bill.
Thank you, Dave. Well, Bill, that was certainly a fascinating view of history, and I think all of us that have been around to see the PC be so incredibly successful have been certainly surprised by how ubiquitous it's become and what a change it's made in our lives. But you also see, as we did down in the museum, all these incredible failures. What's been the failure that surprised you? What's the technology that you believe, besides Bob, of course, that you believed would catch on that hasn't really caught on yet?
Well, someday speech will be a primary way that we interact with the computer. And in the 1960s, DARPA was funding a lot of good speech recognition work. The demos were cool. And, it just seemed to be a matter of years before we'd get to that magic threshold where the recognition was there. Then later we had a wave of these tablet-type machines, with ink-type input. And at least in its first incarnation, that was a big failure. So I'd have to say that the challenge of getting natural interface technology to be so reliable and that people have a model in their head of how they're supposed to use it, bringing that into the mainstream, that's still the thing that surprises me the most. Now, I'm stubborn. In both of those cases, we're spending hundreds of millions a year. We absolutely believe that there's a magic point, and we don't know where it is. We don't make too many predictions anymore. But where it'll just become obvious. Kind of like graphics interface, where there was about 3 years where people argued against it, and then all of a sudden there was a day where, people didn't even want to discuss it anymore. And so the people who've been promoting it didn't even get, a moment of victory, because as soon as it was clear, it was just, let's move on and argue about the next thing. Speech and ink will be like that, but they're not mainstream today. And, it'll certainly take some number of years before they are.
And ink seems to be picking up speed. I mean, we had all these early attempts that failed because the systems weren't good enough, the recognition wasn't accurate enough, and typing was frankly better because of that. But maybe that'll go away. Maybe our grandkids won't have to learn how to type.
Yeah, the first wave of those machines was certainly in an era where we didn't have wireless networking, the miniaturization wasn't the same, and the actual software power behind our ink recognizer now. There's a ton of machine learning. There's a support vector machine, a Bayesian inference machine, a lot of things to get that dynamic flexibility, even to start to get the market going. So we think we've got it. We also didn't do what some of those machines did, which said you had to start over to get ink. That is, you had to go to a new set of applications and a new user interface. Here we're saying, hey, it's like a portable PC, but we just layer that on, and we get the hardware guys to do more and more evolution there. So I think that's the one we're fairly close on. With speech, the place you would see it first catching on is in Asia, that is in China and Japan, where the keyboard is at a relative disadvantage because of the size of the alphabet. In fact, we had this challenge at Beijing University of the fastest typist versus somebody doing speech, and who could get to a perfect result most rapidly. And that is a case where speech is the winner.
Well, so it is really making progress. When I look at this film and I look at the section on the internet, I think all of us were somewhat surprised by how quickly the internet and the web became a tool that everybody started using. And now we do so many things that way, whether it's banking or shopping or getting your information, getting news, trading your stock portfolio, checking Microsoft stock price, whatever. But we've given up something in that. Clearly, we've given up something in terms of some privacy. There are issues of security that people are worried about. How do you think about making that trade-off? And I guess, second, how do you think about ensuring that Microsoft is giving us many of those advantages in their software systems without making as much a trade-off, particularly on the security side?
Well, there's no doubt that every year internet use is just going to keep growing, and there'll be some of the crazy things said in the 90s that will actually be true someday. It just takes more time for the quality and the infrastructure and the general acceptance, the breadth of applications to be there. And so percentage of books bought on the internet, goes up every year. Movie viewing over the internet today, a tiny little number. That'll be a huge number. In fact, we believe that all the cable and telephony infrastructure will be built just around an IP approach. So every movie, even what would have been broadcast video, will be done with an IP stream. So the inexorable increase in popularity at a reasonable rate is kind of an unstoppable thing. The thing we could do to accelerate that the most is take some of those negatives that you mentioned and mitigate those through the magic of software. Spam is a good example of one where I'd say we're halfway towards solving it. The kind of filtering technology that we're doing today that's based on looking at the mail, looking at what it links to, looking at the IP address it comes from, is actually filtering out overwhelming amount of the spam. The amount of spam that people actually get in their inbox in, say, Outlook and Hotmail is down from a factor of 10 from where it was a year ago. There's this one other piece about so-called sender ID verification that we need to get into place, and that will bring it down dramatically again. And I think then we'll be able to say, hey, spam is not this huge problem. Identity theft, phishing, there's a technology we call a card, an info card, that we need to get in place so that as you're interacting with a site, you understand, is it a major site, or is it a site the Better Business Bureau knows about? So you have indirect reputational aspects, not just this master registry that you'll know who you're interacting with. And we can make that very simple. Security broadly is the toughest one of all, because the magic of the PC is we let you run arbitrary code. And arbitrary malicious code is very powerful in terms of deleting files, sending out mail messages, and teaching the user various models of, okay, this code is coming in, do you want to let it do these things? It's very hard, anything in between, okay, just let this code scribble on your screen and use temporary storage, versus let this code do anything. Explaining any tiers in between is hard. And we had this notion that, hey, if we put up a dialog box that says this might be dangerous, think about it, that people would think about it. And what happened was that they got so many legitimate enclosures that their mind, at just sort of a nerve level, would see that dialogue and click on it without any thought at all. And so it turned out the filtering had to move back into the server infrastructure to actually look at the signature of what was there, or even ban sending executables that were non-signed executables, so that you actually had to go a little bit more overhead if you wanted to get that type of file sent out to the system. So we were naive about the social engineering. Today, there's some crazy things where people get you to click on something, but what you're seeing on your screen, they put a button behind that's the authorization button. And so we have a way of fixing that. I think most of these security problems are solvable. We're being forced to invent new things, new methods of isolation, going beyond the simplistic firewall to use web services and IPsec, methods of updating so that for systems that have to be exposed, they get good code faster than they get bad code, and methods of proving out software. When I left academic computer science to start Microsoft, I thought, hey, that we're just on the verge of proving programs correct, and maybe I'll miss that. Well,
you didn't miss it.
25 years later, we came to a situation where we had to prove them correct, and it was a phenomenal thing that the work in the universities and the people in Microsoft Research kind of got together and said, hey, maybe there's a way of simplifying this. And so now we are, in many key areas, proving out properties of our code. And the abstractions between our code, the contracts between the modules, are far higher level kind of guarantees than we've had before, so we can get the benefit of modularity. We're having to invent things to drive reliability to a new level. And we're the furthest along on that because we're the most attacked, and therefore we need to put the billions in to get that right. The weak link that's emerging is actually the password. People hate changing their password. They pick very guessable passwords. And so we're just going to have to move to some sort of smart card or biometric authentication. It'll take 5 or 6 years, but there's no doubt that has to come in order for it to get the level of strength of all the pieces, the software reliability, knowing who you really are, knowing that things can't be spoofed, get that largely in place. So I'm optimistic about it, even though the expense of doing it is extremely high.
So do you think, because of the fact that it doesn't take very much computing capability to basically make a universal Turing machine, in some sense there's always this game of catch me if you can. You raise the wall, the other guys figure out how to come over it at a new height. Do you think that the wall is getting high enough that the number of people who can stack the ladders up and get there actually begins to be reduced over time?
Well, what you have to do is reduce propagation through isolation. And the internet today is just wide open. Somebody who's malicious, whether it's our software or Linux or any other thing, they can propagate things at a rate that's quite incredible. When people talk about biological epidemics, that you actually have time to spread from one organism to another. Here, within a matter of minutes, you, by enumerating IP addresses, can find every machine on the internet with a certain characteristic. You can infect millions of machines. And so that idea of being able to scan arbitrary addresses and being able to go in and probe machines, you've got to have isolation. There's no way, even with new software techniques, that you can avoid using isolation. Things have to be isolated by default. That is, the systems that you're willing to talk to and take code from, or even data from, because data can be malicious because it triggers some fault in terms of how the software handles that data. You have to think twice about the sources of those data. And strange code or data coming to your machine the normal machine should not be configured to do that. And so you need some type of trust relationship before you take that in. We don't have that on the internet today. The internet's missing QoS in the backbone. It's missing a guarantee that the packets really come from whom they say they come from. It's missing the ability to have an abstraction where you can deliver data along guaranteed physically parallel paths. There's a number of things that, all of the internet's brilliant, that show back to some of the early assumptions. One of the early assumptions was one of the internet nodes might get bombed out, and so you should be able to reroute around it, but not that it would be taken over by people with malintent, and they could send this fake routing table and make everything, come to this one location. It is whether we layer on these things on top or actually change some of the underpinnings. That's actually an open question that I think actually deserves more debate and discussion than it's gotten to date. And it's not just the software element; it's the very protocols could give us a stronger foundation.
Right. Well, we designed those protocols in a time when we expected people to be responsible and well-behaved members of the community, and it was a whole different time setting. You touched on the issue of buying videos or movies across the internet. I think one of the things that surprised all of us is how slow it's been to get content providers to think about that. How do you think about the role that digital rights management has to play versus the role of new business models in trying to change what content is available on the internet?
Well, the problem that the music industry has run into at the consumer level is not just unique to the music industry. The movie industry will experience that, and hey, the good old software industry, our things are about the same size, actually a little bit less than movies, but a little bit more than music. So this notion of will there be license fees that the consumer market is willing to pay is a very interesting one. Fortunately for us, we sell a lot to businesses, and particularly in Europe and the US, the willingness to license software on a legitimate basis, if we make it simple and low cost, is very high. And so we can know that we're going to have lots of leakage in the consumer market and still be able to invest over $5 billion a year in the R&D piece. We think there will be reasonable digital rights management, and that's because even if you put aside music and movies, when you have medical records and tax records and confidential communications about earnings announcements that people, because of laws, aren't supposed to be able to get at that information, you've got to be able to make security guarantees. You've got to be able to send a piece of mail and know that the way keys are distributed, only certain people can read that email. Now, it turns out that infrastructure that does that for documents also can be used for media-type things. Have we solved it where it's simple enough for people to use, simple to set up, it doesn't impede legitimate usage? No, that really isn't there. I mean, even with music today, let's face it, people aren't buying their entire music collection because they don't have transportability that if they buy a new player from someone else, they can move their bits over. So if you spent $5,000 to buy every tune you were interested in, you don't want to rebuy it, and yet that rights aren't held up in the cloud in an abstract way that's independent of the set of devices that you want to exercise your rights against that are going to shift over time. So we're really inadequate. I mean, we got something that's semi-decent, and we drove legitimate music licensing up to almost 5% of the music that's used online. Not much more than that. We can strike a good equilibrium here, and it's not giving up on intellectual property licensing.
How do you see that? I think all of us hope to get that. How do you see that intellectual property balance being established as increasingly, Microsoft's products go abroad to China and to India and to other places? I mean, that must really worry you given the lack of attention to IP ownership that seems to exist in other parts of the world.
Yeah, it's a big upside for us if we can move from being just another flavor of free software in China to actually being a commercial software provider. And that's why it's ironic. You get these articles about, hey, open source is more of a threat or something in these other countries. Not a chance. I mean, you get Windows for nothing, and so you can do exactly what you want. That will change over time. As economies develop, at least the business sector's willingness to license software increases. And so Taiwan, Korea, Hong Kong, if you go back 15 years ago, they didn't buy software. Today, their compliance level is almost as good as the United States. Eastern Europe actually has a compliance level as good and actually better than some other European countries. So that it comes with time. You need the models, you need some level of enforcement, you need the prices to be viewed as extremely reasonable. And we may have to do more tiering, our educational price, home use price, small business price, make sure that we're adjusting those things in the right way. But I think the business market will come. The consumer market, that's a tough one. And there are devices like video games that come with a very strong protection scheme. Xbox today or PlayStation 2, if you don't hack the hardware, that protection scheme is held up, and that's key to the business model of how that works. And so I think we will have that kind of enforcement. Again, we need it because people want privacy, and the only way to have privacy guarantees is to be able to secure information.
What do you think about this issue of what people invariably call information overload or being connected too much, whether it's among our kids or among ourselves? I mean, we're always connected now, wireless. You go to Starbucks, you don't just sit there and have coffee, you read your email now. And similarly with information, we have such an array of information services. How do you think about managing that in a way that it really improves our lives and personal productivity for all of us?
Well, I think there's a couple things. One is that software can do a far better job for you. The idea that if you have your inbox open, that everything flows in it, from spam that's worthless to things that are very important. And if you're thinking, doing a presentation, all that stuff just keeps coming in, as opposed to knowing the mode you're in and having a threshold and a context that varies so that you don't get interrupted unless it's something that's actionable and important based on who it comes from, what that thing's relate to. We need software to work on your behalf. We have these inbox rules today. Some people use those to good intent, but they're still too hard to set up. And we don't learn enough implicitly where we watch what you look at, what you do with it, and act on your behalf. And so that's one of the Microsoft research projects, is to think about not just email, but all communications and information changes, and how software is your servant, knowing that your time is the scarce resource and when you want to use it for various types of things. The second thing is that people have to exercise judgment. I was on vacation last week. I don't happen to do email at all when I'm on vacation. I just don't. There's no reason to. It does mean that day you come back, you kind of have a lot of email sitting there, so you have to actually block some time out maybe to get through that. But I think it's partly we're just getting used to this. It's like when we got fonts and graphics user interface, people said, okay, fonts are bad, all these icons are bad. Well, yes, we overused fonts and icons for a while. When we first got colors, we thought, oh my God, let's use them. But now it's more logical. You're going to have connectivity everywhere, which is a fantastic thing. It's an empowering thing, and you'll have to decide behaviorally how to deal with that. And parents will have to work with kids in terms of what kind of activities do they want to set limits on, and get the right balance there.
Yeah, I must say I spent 2.5 weeks in Sicily, and it's hard to find internet connections in Sicily still. So I recommend this. It gives you lots more time to enjoy a wonderful country. So we're going to open the floor for questions now, and I think we have a couple microphones there. So if you just come up and tell us your name and give us a question. And Bill said you can ask him anything you want.
Hi there, my name is Andre Lamotte. A question that I had, in future releases of Windows and various technology, what's your thoughts on grid computing and giving access to developers to use nodes? Of course, with security, et cetera, would have to be in place, but it seems like a lot of waste of computers not to be able to do grid computing from a PC.
Now I'm sorry, what's my thinking about?
So with the new operating systems like Longhorn and so forth, right now we've got a huge underutilized set of computing systems. And what I'm wondering about is grid computing and what Microsoft is going to be doing in the future with that, so that we could use it as developers sometime in the near future with Microsoft operating systems as the hosts.
Sure. Well, there's a lot of grid-type things being done on top of Windows. We've got a group now that's making sure the Beowulf implementations are really great there and all the applications are there. It really varies by application how much it's worth it to ship data off to a computer that's far away, have it do some computation for you, and bring it back. Say that computer is free, you still have the latency and the data network cost. And actually, Jim Gray's done some great papers on trying to classify things and looking at cost trends and saying, what applications do you just want to move within a data center, and what do you want to move out to the grid as large? The term grid is being used very broadly. We use it in a very broad sense. We think of, hey, distributed computing and scheduling things, that's grid. The extreme case is something like a cryptographic attack problem, where it really partitions itself beautifully, and the amount of state you need to send out over time is just this tiny little thing. Compare that to, say, a weather simulation problem, where the amount of data that as you're doing the time sequences in the physical regions, you're generating lots and lots of data. There, it doesn't make sense for weather simulation to send it out to lots and lots of PCs. It takes longer to send it out and get it back than it does to compute that information locally. So that's one where a, quote, grid, but more like a cluster-type grid with, say, thousands, not millions of computers makes sense there. We are building into our web services capabilities rich notions of resource finding and scheduling. So we're supporting the Beowulf stuff, but our view is there's a whole next generation of this distributed computing, scheduling, resource finding that's being built down at the web service level, and we're very excited about that. So you'll see more grid things, no matter which definition you happen to use.
Isn't security a big piece of this, Bill? Because I know we had a case where somebody cloned one of our faculty members' code for doing protein folding in a distributed fashion, folding at home that let people do this, and sent somebody a virus. And this guy thought this was the legitimate, he was helping do science, and lo and behold, he gets a virus on his machine. Who does he call? He calls us, not the person who generated the virus.
That's right. It's the ability to partition off this thing where you're willing to grant some use of your machine. There's a lot of trust element in that because, and that's true on both sides. The person sending you the code can screw you, and you can say, hey, here's the solution to this protein problem, which is just completely fake, and mess up the other person. And people have talked about this in terms of data storage, that why can't I use the spare hard disk capacity on other people's machines? Well, we do have, Microsoft Research did what's called a Byzantine algorithm, that it takes collusion on an extremely high percentage of the people, because we send to 3n+1 machines. It takes n of the people to have colluded in a known way in order to fool you that they messed up your data storage. So there's a huge overhead that, again, pushes out the class of these problems that can be used in the broadest sense, overhead to ensure the integrity and security.
Let's go over here.
Brad Templeton. So 2 security issues that you touched on, which I think need some interesting exploration. First of all, I've actually applauded Microsoft for promoting IPv6 in Windows XP and returning to the end-to-end principle of the internet, but you spoke of a belief in firewalls as the ultimate security solution, which are unfortunately a reversal of that trend. And the second question, with DRM, most of the geeky people I know, and I'll count you among us,
Say again?
With DRM, most of the geeky people among us, and I'll count you among us, believe that because of analog, what Jack Valenti so nicely termed the analog hole, that DRM is not technically feasible against people who really want to attack it. And if you agree with that, and I don't know if you do you believe it's a worthwhile course because of that?
Well, take medical records. Should they be private or not? And should we as an industry invent and support technologies to keep medical records private? I say we should. There's no analog hole equivalent there. We should have DRM capabilities. When somebody sends a piece of mail inside a company, should they be able to limit how much forwarding takes place to that email? Say it's a financial thing before the close of the quarter and only certain people you want to make insiders. Should you be able to limit that? So I think there are things that are clearly needed and require a DRM infrastructure. It's absolutely the same infrastructure. In terms of the will it ever work, that all has to do with how easy and attractive you make it to buy stuff legitimately. And we can still criticize the music companies and the studios, even though they've taken steps. They still don't make it easy. This thing of migrating between devices, they don't make easy. The movie guys don't even have the stuff out there broadly. The ones that have it out there have it on a very delayed basis. And so there'll be an equilibrium of stolen and paid for. And by not making these things available through easy download with reasonable rights, they're affecting what that equilibrium is. I'm not somebody who believes that no one will ever pay for music or movies ever again, and that will destroy the incentive system that allows people to create those things. I just don't think that's going to happen. I do think that in terms of sharing with other people so-called darknet, you cannot intercede darknet. It's when you start to go to global directories and say to people, hey, to strangers, I'm available to provide you this material. That's where possibly, not necessarily, possibly you can get intercession there so that you don't have the ultimate friction-free stealing of bits there. But that will be played out over time. An analog hole, we can't solve that from the industry. What they said to us was, make your player do signature detection so you can say, oh, that's the Beatles, and then go look to the master repository of is this guy paid for that, which of course doesn't exist, and because you can do CD ripping and everything, and make us the enforcers. And one thing we've been clear on with the media industry, we will not be the enforcers. If they put envelopes on things, if we see envelopes, our software won't be the thing that goes around those envelopes. But if things come in raw form, we're going to treat it in a way that we don't do recognition against it. So the analog hole, they're just going to have to deal with that. The key question is, as they go to HD, will there be an infrastructure that makes it harder for the bits to be stolen than there's been in the DVD world? And that's something that reasonable engineers disagree about whether that's achievable or not.
Mm-hmm. Well, it's a big long line, so I don't know if we get to the end question, but if you have time.
No, I'm sorry, what was the first? Yeah,
well, it was about the contrast between the firewall approach to security and the end-to-end
good point.
application design.
End-to-end is super, super important. And if I ever say anything that seems to contradict that, Jawad sends me mail, our networking guy, because these NAT approaches it's terrible. All our neat peer-to-peer stuff gets messed up by it. A firewall, it doesn't have to be a violator of end-to-end.
It doesn't have to.
No, it doesn't have to be, but it basically is today. The right answer is the web service approach, where we're a combination of IPsec with web services, where when you try to get to a machine and ask a machine to do something for you, you can reliably tell it who you are, you can reliably know if it's who you think it is, and then based on a web service by web service basis, you decide whether to provide admission. And there's nothing in the middle that has to be able to cryptographically break the information. It's just you're communicating directly with that machine. So what we need to do is move from the firewall approach back down to the individual machine. And we think the web services evolution gives us a reasonable step-by-step way to get there, we hope.
Let's go over here.
Hello, Gerwin Kasalker. I read a while back that Google has received a government contract to use their AI technology in our search engine for tracking terrorism activities. Has Microsoft received any government contracts, if you can disclose that? And where do you see some future trends in Homeland Security and what's needed?
Somebody got a contract?
Google, I read about this, that they may be getting government contracts to actually do the AI technology in a search engine to track terrorism activities on the internet. And so they're kind of getting into the government sector. Has Microsoft been involved, if you can disclose that? And if not, if you can't disclose that, do you see any trends that are needed in the future with Homeland Security software?
Well, no, we're not, certainly in terms of that specific thing, we're not involved in anything like that. We do get search warrants like anybody does where somebody comes to us and says, hey, a judge has granted access to this email account, and can you give us that access? And there's a procedure for that, and we have many people whose full-time job is just to cooperate and make sure we're doing those things. And that happens with other foreign governments as well, but it's all based on judicially defined processes. We don't do special software for Homeland Security or CIA. Our platform is used by them, and we're enthused about that. One thing that we ran into is that governments around the world thought that maybe the Windows security system was spiked in the favor of a particular set of security agencies. And so we needed...
a little trapdoor maybe, or something?
Yeah. So we needed to do two things to avoid that. One was to give them the entire Windows source code and show them that the source they had and the binary they had corresponded perfectly and they could look through. And so China has the source code, and they really did look through it. Russia has it. A lot of governments get it and just put it in a closet because it makes them feel good. But the Chinese did not. They went through this. We also made Crypto API a pluggable thing where you could add your own crypto in. So if you like some different algorithm, then that's fine. You can do the key generation and the encryption down in that piece. And that was very important so that people could know that the software is an honest broker and not giving somebody an edge in terms of getting into your information. And so we have to be very, very careful about that.
Okay, thank you.
How about over here?
Ilya Gluchovsky. I actually had a question about firewalls, but to avoid repetition, what was the last time you had a virus on your machine, and did you do anything else about it besides downloading a removal tool or handing it off to your support? Thank you.
Yeah, because of the way that our machines are scanned every time you log on, if a machine has been outside the firewall when it comes in, it's automatically scanned. I haven't had any viruses on my machine basically ever. I have had malware, adware, malware, that crap, on some machines at the house. And so I have had to run scanners to eliminate some of those adware products. And partly as a result of that experience, Microsoft is going to itself provide malware cure software and keep it up to date on an ongoing basis. That's become really, the good news this year is spam has gone down, and our people's perception of us is really working with corporations to make their network secure has gone way up. That's the good news. The bad news is this malware thing is so bad, and so now that's the one that really has us jumping in and needing to do a lot of dramatic things.
Yeah, well, one of the things we see as a university is every time the students arrive back on campus, they come in with their PCs loaded with a whole new set of viruses and proceed to hook them up to our network. And then all of a sudden, something which you thought you had wiped out is reborn on campus, and you've got to. So we've had to be really tough, much tougher than I think we'd ever want to be with students about saying, if you don't update the software, we're not going to let you on the network because you're going to threaten everybody else.
Yeah, and that forced update, like forcing people to get up to SP2 or something, that's something we're, of course, pretty rigid on the Microsoft network and trying to show other people how it's easy for them to do the same thing.
How about over here?
Hi, Chris Primesberger. I'm the editor of IT Manager's Journal. Question, Bill. There's a report that almost 50% of servers being sold today are running Linux or some kind of open source system. What does Microsoft have in mind to help counteract this trend in the marketplace?
Well, you should just go get the numbers from the reputable people who track the numbers. It's just not a right number. I mean, go get the IDC number or anything. Well over 50% of servers that are sold run Windows Server. Windows Server share by everybody who tracks this stuff, and there's 5 people who do it really well, went up last year. So, first start with the facts, then proceed from there. We do compete with Linux, and the shift of Unix share to Linux has been dramatic. Linux is now the dominant share of Unix, and it'll wipe a lot of the stuff that's been out there down to very small numbers on current trends. And so if you look forward in the next 10 years, a lot of market share will be whatever Windows is used for and whatever Linux is used for. Now, I'm not saying that's all they'll be. I mean, Sun is still enhancing Solaris, Apple is still enhancing OS X, but those two will be the big numbers. And so, we have a clear competitor. Microsoft has had clear competitors in the past. It's a good thing we have museums to document that. I'm not saying this competitor will go away or anything, but OS 2, was going to kill us, and IBM, who had 10 times as many employees as us, said to me, we will put you out of business with OS 2, which is this long, complex history where originally we were part of it, and then they kicked us out, and then they tried to kill us with it. And the same thing was said about Novell will kill us, and Borland will kill us, and different things, and that makes my job interesting.
But Billy, I think the Unix history is an interesting one because the inability of the Unix vendors to come together on a single standard for so long really did harm them because it made it completely much harder to get other software, to share technology, and now to have a piece of freeware come along and really finally unify the Unix market is a very strange phenomenon.
Well, I don't think so. I think we can understand the incentive system that led to this result. The number of press conferences where various Unix vendors would sit down and say, hallelujah, we're all as one. Those would happen, every 6 months, 8 months? But the day after they left the press conference, the HP engineers were told, hey, we pay your salary, make HPUX better than AIX. And this is a capitalistic society where people like to have money to send their kids to school. And so those HP engineers did a good job. They made HPUX different. So everything that was state-of-the-art, whether it was directory, security, graphics, they would do enhancements. And anytime one company threatened to get a big share of the Unix market, like Sun was the primary one there, the rest of them would all get together and do like the Open Software Foundation and swear that they were as one. But as soon as they had any degree of success, they were not as one. And so you can't get commercial cooperation where you're out in the marketplace the next day trying to compete on those things. And so Windows was one company, one incentive structure, and Unix was not.
I think you're right.
Great. Hello, Mr. Gates. I'm Jefferson Lilly with VeriSign. I'd be interested in your thoughts on basically the intersection of enterprises and wireless, and in particular, your views on how businesses are deploying wireless technology to communicate with employees, customers, and/or to do commerce.
Well, wireless is very exciting. The concrete piece of this is the growth of Wi-Fi. Wi-Fi being built into all the portable devices, Wi-Fi being able to use dominantly a VLAN approach that will let somebody come onto your business site and have guest access and even be able to get through to your printers on an authorized basis, and yet being able to connect people up to the corporate network on an authorized basis. So another thing happening in Wi-Fi is having enough QoS prioritization that we can put voice packets on there and roam your telephony onto that Wi-Fi network as well. That is a very exciting thing. So Wi-Fi is exploding. It's in more and more locations. The idea of how you secure it is becoming clearer to people. The speeds are going up. Then in the meantime, you have at the short distance, ultra-wideband, that Intel and others will make practical within the next 2-3 years. That is a huge contribution because in terms of connecting screens, printers, peripherals, USB that has been a fantastic success with Microsoft, Intel, and a few others making that. A lot of what's done on USB will just move to be wireless ultra-wideband. There's actually some security authorization things in terms of what the association between the different elements are that is actually the trickiest part of that has to be worked out. Then in the wider area issue, it's either meshing together Wi-Fi or taking things like WiMAX that'll bring the longer distance stuff down to low prices, that equipment. Again, Intel and others, but Intel in a fairly key role there. That's going to drive wireless into a stronger position, particularly in developing countries where connectivity costs are holding things back. So, we are in the golden era of wireless starting now.
It's a good example of a technology which there were many attempts at doing it earlier that all failed. Home RF, we had all these attempts at it. And then all of a sudden, boom, it just takes off. The technology got to the right price, I suppose. It got robust enough. It worked well enough.
Yeah, it's a tipping point where people hear about it and they think, okay, this really is the way you ought to do things. And it's the combination of broadband into your home and then wireless in the home. That's pretty fantastic. The number of things you can do at that point, the way you think about the internet and computing, it's just very different. And the magic of semiconductor economics is really something. Volume means things cost just a few bucks to do, and then they just come standard.
All right, let's go over here.
Tony Mazzapelli. In this month's Scientific American, there's an article by Ted Salker from MIT about e-voting machines. Voting is pretty important in our society, and there's a lot of potential problems with the box itself and where the information goes after you do the voting. Do you think that private companies like Microsoft or others should be the ones supplying the technology for e-voting? And a lot of people say that the transactions should be pretty simple, like doing an ATM type of transaction, but there's a difference between voting and doing an ATM. You have a relationship with a bank and you can go and review your data. In voting systems, you cannot.
Well, I don't think that's the key difference. I think the key difference between voting and banking is the number of people you have to convince that the thing was right. You just need to convince people who understand the technology deeply who can audit the thing. You need to convince a very small number of people. The people in the bank itself, the people that audit the bank. Whereas in voting, you need to convince the public at large. And so you can't, it's very hard to have something that's complex technologically that you can ever convince the public that the gurus didn't find some way to get in there and mess around with it. And because the desire to have integrity in that system is so high, relative, at least in this country, the desire to do it efficiently, I don't think that's a very attractive market. I mean, people can build software on top of Windows to do it. That's fine. We ourselves are not going after the e-voting market or the nuclear reactor control market. Those people who want to make the proofs and do those things, that's great. They should do that. But it's just such a sensitive area. And, so why not just spend a little extra money, print out little slips like mad, do it in a way that Joe on the corner can say, okay, you pull a lever, a piece of paper comes out, it goes into a box, only this guy has the key to the box. Very, very simple things like that. Software is magic, and people don't want magic, too much magic in their voting integrity chain.
We know what happens when there's too much magic.
Okay, unfortunately, we're about out of time. One more question.
Hi, Avishai. I wanted to ask your opinion about the developing technology of network attached processing, which will allow servers in the IT rooms to have practically unbound compute power of any operating system.
I'm sorry, what are you saying?
Networked attached processing. And that's a new technology that allows servers to attach to compute pools, and it's currently available for Java. So how about .NET?
Well, certainly the basic idea that we're abstracting away the presentation from computation from storage, that's happening in many, many ways. Ultra-wideband is going to drive that for the PC, where you'll just have storage in your pocket. You'll have various displays around the home. You'll have computing things. SANs, basically, what you're saying, SANs did that because they took the storage away from the servers, and the servers became a compute pool. So we don't need anything new to have that abstraction. There are better and better ways to do that, including these very deep scheduling algorithms that will get attached to the Bay-Wolf clustering APIs, will get attached to the web service APIs. And so we do want abstractions that can locate resources, compare your query of what resource you're looking for between what's being provided in this very rich way, that kind of auto-discovery thing. So we absolutely think getting at compute clusters is going to be important. Another thing to remember, though, is that, in a sense, that's not the interesting problem today. Calling up an IT manager and saying, hey, you can buy half as many servers is not as interesting as calling up an IT manager and saying you can have half as many people, or saying to them you can write half as much code, or that your systems will be reliable, that you can sleep at night. How about that? And we are buying, Google and Yahoo, because these master web services we're doing around mail, storage, and search, we're buying more computers and disks than anyone on the planet, the three of us. I mean, it's just incredible, and we're just putting them together. And we're learning more about failure of PCs, when they fail and how they fail, because we build this system so that if nobody goes near it for 90 days, it will keep running. And then every 90 days or so, some guy goes in and just plugs in a bunch of commodity things, and they get auto-recognized, and he walks out. And it'd be neat if I could buy those things for a little bit less. But it's actually the software innovation of how we make sure that there's no single points of failure, and we don't have to think about them. It's the personnel cost we're saving that really is the magic thing. So, I think, great, let's use more of those computer resources, but let's also keep in mind where you get human costs in updating and reliability and security vulnerability. That's where we can really take IT budgets and reduce what we're spending today and take whatever that opens up and say, okay, look at tablet computing, look at wireless, look at new workflow approaches, look at new business intelligence, and get value without having to spend net any more money.
Yeah, I think I never would have gotten to the point where I would say, hardware is cheap. It's not the problem. It's all that software. It's making stuff reliable. It's knowing that whether it's a Microsoft website or a Yahoo website, it's going to be up, and that you can maintain all these things. And not spend all your time installing new software and keeping your machine up to date and doing all those kinds of things.
Yeah, just a historic note on that. You know, and to me, this is actually kind of a sad thing. When I wrote 4K Basic, I knew every byte, and I told everybody who looked at it, hey, if you can save a single byte in this thing, I'll pay you $20. And nobody ever got anything from me on that. And I know that program by heart today.
You should do that for Windows, Bill.
Today, if you're a programmer today, you don't know, you could allocate 400K without even thinking about it. And you know, maybe somebody might notice it a few years later that you accidentally allocated 400K you didn't need. So in a way, you know, I am an old tinker type, and they've got the paper tape of the basic that we did to prove it. So,
yeah.
Thank you so much, Bill and John. I know that we'd like to go on forever, but you've got scheduled.
Yeah, thanks. That's great. Okay. Thank you.
Thanks, Dave.
Thank you.
Thank you, everybody.